Alright, here we go. Welcome to my makeshift physics lab. We're going to do a couple maths. Problem 3. Here is how it looks. The only information given to us is that mass number 2 is 20 kilograms, mass 1 is 10 kilograms, and the angle is 30 degrees. Alright, here we go. Mass 1. First step is to draw the free body diagrams. So mass 1, we're going to do, it's on a slant. Here is the object, and we're going to make the axis, or the axes, it's going to be going, the x-axis is going in this direction, diagonally. So we have the normal force going out, and the force of gravity in the y direction. These will be equal in size, and these honestly won't even matter. What matters is the force of gravity in the x direction and the tension force, which goes into my M1 letter. The tension force is going to be bigger. Force of gravity in the x direction. Mass number 2 is a little easier to draw. The force of gravity is going to be bigger than those. Is that going to be really big? Ooh. Force of gravity, and the tension force is going to be the same because these objects in coupled masses experience the same acceleration. Alright, let's get to problem solving. Start with Newton's second law. Sum of the forces equals ma. Oh, sorry. Sign convention. The mass system will accelerate in this direction, so everything going in this direction will be the positive, we'll call it the positive direction. So we'll call this negative, this positive, because it's moving like this. This is positive, force of tension is positive. Then here we're going to call this positive and this negative. This will come into play when we cancel out force of tension to solve for the acceleration. Alright. Back to here. 2gx 1. We're only focused on the x direction. Like I said, these really don't matter. So force of tension minus the force of gravity in the x direction, which we know is going to be m little g sine of theta equals m1 times the acceleration. If you plug in some numbers, some things that we know, find ft minus, the mass is 10 kilograms, the acceleration due to gravity is 9.8, sine of 30, that all of that together is 49 newtons, equals mass 1, 10 kilograms times the acceleration. Shimmy over here to object number 2, Newton's second law. This is a little bit less complex. Force of gravity is positive minus the force of tension equals mass 2 times the acceleration. This is mass 2 times acceleration due to gravity, which is 196 newtons, minus the force of tension equals 20 times the acceleration. Now we have ourselves a system of equations. I'll just put that up there. 196 minus the force of tension equals 20A. Fumble. Plus the force of tensions will cancel out. We have, I don't think I actually figured this one out. Yeah, I'm gonna need a calculator. Ow. 49 plus 196, 147. 30A, divide both sides by 30. You get 4.9 meters per second squared, the acceleration. You want to plug that in to this right here, or we can plug it into this. I like that because no negative. Force of tension, sorry if you can't see, force of tension equals mass 1 times the acceleration times mg sine theta. Mg sine theta is 49. 49 plus 10 times 4.9 force of tension, 49 plus 49 is 98 newtons. All right. There you have it. Coupled mass problem 3 in its entirety.